All right, chapter 7. Okay, we will not finish it today, by the way. We'll finish it later. Okay. Wide area networks. Okay. All right. What's the best example of a wide area network? Anybody? No. How about the internet? Isn't that like one big massive wide area network? It's stuff everywhere. Okay. Wide area is a network traversing some distance, connecting multiple LANs together, which the internet does. Transmission method depends upon business needs. Some people get faster connections. Some people get slower connections. I went home last night, and man, I was getting like 0.5 meg download speed on my iPhone through my Wi-Fi connection. I'm like, what the heck? I was going to go reboot my router. I restarted my phone and fixed it, but it was weird. I've never, ever had that issue. It was just crazy. So at that point, my speed was very bad. Okay? LAN and WAN, common property. Okay, basically we have hosts and clients. With the internet, where all the clients and the servers are the hosts. Easy enough there. Okay? There's layer 3 and higher protocols. What are some of the higher protocols?
Layer 4.
Well, pretty good. Layer 5 even. How about like HTTP? That's a big one. SMTP, email. There's a lot of different protocols we use on all this. Also uses packet switching digitized data. You know what packet switching is, don't we? That's when we take our whatever we're trying to transmit, break it into pieces, and send it across piece by piece. They can go different routes. They can go the same route, but they don't have to. Okay. And I was moving a bunch of crap out of Norman yesterday and over the weekend, and I had to put it in boxes because I can't carry it all at one time. So I put it in a box, carry the boxes, and then just pile in the. We're gonna have a huge garage sale in the spring to get rid of all this crap. So if y'all want free stuff, come to my house. I got tons of it.
Hey, since I'm giving her the boxes, I get first pick.
Dude, you can come and have first, second, fourth pick for all I care. You know, I have this desk. It's like a cubicle type thing. That's like the size of that wall. Someone wants it, come get it. It's free. I mean, you can have it's got like desktops on it with little cabinets above them, and
My wife would kick the crap out of me if I bought that.
it's at least it's nearly the size of that wall. But it's in pieces. They can come apart. So you can have just 1 or 2 or 4 or I got a bunch of crap we can get rid of. But okay. But packet switching is how the internet works. That's one of the best things about it. Because can you imagine if you were watching Netflix and you were the only one that could do something on the internet until the movie was over? It couldn't happen. There's no way that could happen. Okay. All right. Some differences. Layer 1 and Layer 2 access methods, topology, and media. Look at the media. Now, the internet media different than LAN media? Yeah, I mean, normally it's fiber optic cable, it's satellite links, so the media we use is different. Topologies, the routing is different, the switching is different. So, like, you really think this switch right here, this chippy switch in this room would work for a high-speed backbone somewhere? No. Put inside Google's network, it'd be gone. It'd be fried in a second. So it's all different, okay? The wiring, it's normally private, okay, and internal to your LAN, so it's internal to real estate. Yet the WAN is really public, but it's really owned by somebody. Who's the largest provider for internet? What do you think?
Cox.
Actually, it's AT&T. They own more of it than anybody.
They have all the wiring.
Yeah, they own the wiring. So, I mean, Cox might have more clients, but AT&T, like, they own the undersea cables and all that stuff. It's all owned by them. So, okay. We also have NSP, network service provider, stuff like that. There's AT&T and Verizon and Sprint. I was like watching those commercials, how AT&T has the fastest network out there. Then very next commercial, Verizon has the fastest network out there. It's like, you seen the new one? So I was watching Amazing Race. Okay. See, I told y'all last week I was going to turn my cable off. I did. Found out they were actually overcharging me for the last 6 months anyway. So they credited me all that money. And then I canceled it. So, so I get rid of that. But we're watching The Amazing Race. It was on CBS.com. You can just watch all of them. But there was a Verizon commercial on there where they show a chart, like AT&T and Sprint and Verizon's way up here. Right, but how about if I turn the chart this way? It's like, I know, it's so skewed. Whoever you talk to, theirs is the best, obviously. Okay, so it's...
Actually, he's in the United States, but money for broadband.
Oh, yeah, we are so far behind. Go to Europe. I mean, I did 2 years ago, I had a British Isles cruise. I had cell phone reception the entire time. So I was actually paying for, I signed up for international data at that time. Everywhere. Took cruises all over Belgium and all those places, and perfect reception. Here, hell, in my office I lose reception. Crap. You know, where was I this weekend? I was somewhere. I was in the doctor's office yesterday on Tinker, the new hospital. That's a very nice building. Very nice. Zero reception in the darn doctor's office. Sitting there waiting for an hour. Phone got no reception. What the hell? That's terrible. Okay. But the WAN size is individual geographic locations connected by WAN. So we have people connect long distance away. Hertz is a prime example of that. Hertz is worldwide. Okay. Or even Apple's worldwide. And Microsoft, there's a lot of places. Even Google's worldwide. So we have a site connected by a link. Some high-speed data link. All right, topologies, okay? The distance covered. Obviously, LAN topologies don't go as far as WAN topologies. Can you imagine using this regular old twisted pair on a WAN link? It's every 300 feet you would have to have something, but we got that whole 5-4-3 rule, so we wouldn't be able to make it work anyway. So the LAN topologies are definitely different. The number of users. A LAN might have a whole bunch internal, but WAN, we're talking more overall. The traffic. Now, what do you think? You think there's, say we're talking, let's say OSU. Okay, OSU's got a Stillwater campus, Oklahoma City campus, Okmulgee campus, and Tulsa campus. Okay, so do you think there's more users across the WAN link or more users on the LAN? I would say the LAN, because probably internal to their local network there's a lot of traffic, and there's some across the WAN links. But, you know, how much of it actually has to go to Stillwater? Not as much. Okay. All right. Different connectivity devices. We're going to see about all those here in a minute. Okay. WAN connections require layer 3 devices. Okay. Routers, basically. Not going to have just a switch on a WAN connection. Will never happen. You'll have a router of some sort. Okay. Cannot carry non-routable protocols. Would you want some non-routable protocol out there? No, because wouldn't know where to go. Okay, imagine a WAN is like I-35 and I-40 and I-240, that kind of stuff. Okay, it's not the back streets into my neighborhood; it's the main intersections. That's what a WAN is. It's an international highway. You know, like I-35 and I-40. You know why it has an I in front of it? Interstate. So why in Hawaii do I have I-1? Don't go between those days because it was made for the military. I did not know that. It's an interstate or military use. And I-1 in Hawaii is made for the military. I was down there on a tour and someone asked that question. Why do we have I-1? There's no other states. So, it's kind of interesting. All right. So there we go. We got our LAN. We have a whole bunch of internal stuff, maybe connected with a couple switches or whatever. They connect to a router. Then they go out to the ISP. Then we have all of our WAN links connecting these major areas together. Okay. When I took care of Chapel Supply, we had their Oklahoma City office where all the computers were connected. Then we had a Fort Worth office where all their computers were connected. And they were connected via a WAN link between the two. Okay. It wasn't a dedicated, they actually were using the regular internet, but it was, you know, their connection between them. Had a VPN, it worked good. Okay. Bus star ring, we're going to talk all that one more time. It's the same. Okay. Each site connects to 2 or more sites maximum. Okay. And different locations connect to one another through point to point. We'll see a picture of it. Best used when small LANs, you know, this place connect to this place. What they're great for. Okay. Drawbacks, you just can't keep adding them. Yeah, I think they have a picture next. So we can connect these two together, those two together, those two together, but you're kind of limited on what you're going to do. You're just not going to want to. Can you imagine if the entire internet was one big bus? So to get from here to anywhere, I'd have to go through every ISP between you and there. That would suck. You want some sort of high-speed connectivity device where, okay, I want to go to Europe. Okay, so I'm going to go over here to connect to this one device and go straight to Europe. Okay, you can kind of think of it like our airlines. You know how we always go through Dallas or through Houston or somebody and then somewhere else. Like I went to Europe and I went through Newark, flew to Newark, and then we went from there overseas. Can you imagine if I had to fly from here to Dallas and then to Chicago and then to New York and to Newark and then to Greenland, and that would suck. I took Anyone ever use the military flights, the free hops? Did you ever use the free ones? I used one coming back from Europe, and I landed in Dover. Is that Delaware? Dover. And I was scheduled to go all the way to Tinker. It was from Germany to Dover to Tinker. The plane broke. Crap. So they kind of leave you there. And I'm stuck in Dover. And I was going to go buy a flight, and there's a really old guy there. And he's like, oh, dude, he goes, are you in a rush? I'm like, not really. He goes, no, don't buy a flight. Just get on the next plane going somewhere. So I ended up going to Charlotte, then to Florida. Then I went down to San Antonio. Then I went somewhere else in Texas. Then up to Tulsa. And then down to Oklahoma City. It took me about a day and a half. One of them was on a General's Learjet. It was like only 4 seats in the whole thing. It was all free. I get in there like, don't touch anything. You just sit there, nice cushy chair. But it was kind of what we're talking about here. I had to hop all over the world, which kind of sucked. But can you imagine the internet working like that, where to get somewhere you had to go through 300 routers? It wouldn't work. That's why when we do traceroute, we're limited to 16 hops. Because, yeah, it might take 1 or 2 hops to get to a high-speed backbone, but then it's pretty much straight shot to wherever you're going. All right, a ring. It says ring topology for ring. It says each site connected to one another. We have a ring pattern. We'll see a picture of that in a second. Talks about redundant rings. You want to have it so if one goes out, you can go the other way. They normally go in the opposite direction. It's difficult and expensive. Okay, and you can see a picture of it. So there we go. So is this a little better? Yeah. Now, if the link, the T1 link at the top goes out, we can still communicate. Or if the T3 on the right goes out, we can still communicate. Now, if we lose 2 of those, we're kind of done. Okay, but this gives us some redundancy. Yeah, if you can't go one way, you go around another way, usually. Like at Rose State right now, all of our traffic goes through humanities. So if the link between humanities and social science goes out, we're done. Now that's changing, which hopefully very soon.
Base used to be off of one Cat 5 cable.
Nice. All the traffic?
A long time, but not anymore.
Nice. Okay, Star, a little bit better. We have a centralized connectivity device, separate buses going to each location. Okay, it says single connection failure affects only that location, just like a normal Star. We talked about that already. If the main place goes down, actually Virginia was telling me today, Tinker, that there's a whole entire portion of their network went down. I guess someone hit the power on the switch or something. I don't know if it was in your area too, but she's like, nope.
We're also in the process of going from IPv4 to IPv6.
Yeah, they're doing upgrades.
She said, yep, we have zero connectivity right now. Someone cut the switch or something. I'm like, great. Okay, so here you go. We could have a Star link, so maybe our Main Street Madison is our main connectivity device, so all traffic kind of go through him. But the good thing about that is if the T1 in the middle goes down, yeah, Watertown's done, but the other ones can still communicate. So it's a little bit better than a bus or a Star. Let me go back a couple real quick. So with this bus here, so this T1 in the middle goes down, you know, depending on how it's set up, you know, Oak Street and Main Street might be able to communicate. They might. Probably could. But Waterton, you know, and Columbus might be able to communicate. But obviously, you know, Oak Street on the left could not connect to First Street on the right because there's only one way to get there. Okay. Now this way here, if that T1 at the top goes out, yeah, they could go one way or the other. Okay. But a Star really only affects one. Okay. Mesh is the best way to do it, but it's a lot more expensive. Okay. And it says data travels directly from origin destinations, and we're going to see a picture of that. A full mesh will never happen. Okay, I'd love to see it, but it's great. It's great in theory, but it's never ever going to happen. Okay, very expensive. Partial mesh is what a lot of places do. With the mesh, basically everybody talks to everybody else, has a direct connection to everybody else, which is great. So on the picture on the left, the T3 at the bottom goes down. Can we still all communicate? Sure we could. So, but the problem is, you know, what if we start adding 10 buildings there? You know, we're talking massively, you know, increase the amount of, it's like keys in computer security, yes. Right? But we have a partial mesh, right? Maybe we have some redundant connections, but not all of them. So maybe Indianapolis is important, but not enough where we really need a redundant connection to them. That kind of stuff, okay? All right, tiered. So sites connecting in star or ring formats interconnect with different levels. Basically, it's like putting them all together. Okay. Hierarchical groupings. We'll see a picture of that one. Flexibility says a lot. Many various practicality says. Let's see if the picture's up there. Yeah, there it is. Okay. So we have maybe one section here connected to another section there, connected to another section here. So maybe we could have it with, I don't know, different states or different areas or something like that. You could, the East Coast, the West Coast, or whatever. So, lots of different ways. Public switch telephone network. So, does anyone agree with me that sooner or later this will go away? It has to. It has to. I was sitting in the doctor's office yesterday. I said for an hour. Phone wasn't working very well because there was no signal. But across from me, I could hear a modem. I mean, it was literally, the old sound. I was like, wow, it's actually a real modem. It wasn't a fax machine. I was like, someone's actually still using a real modem? Anyone here use a modem still? Oh, no one wants to admit it? No one does dial-up in there? There's usually somebody with dial-up. Nobody has dial-up? Arlene. I remember when Arlene had dial-up, because the school offered it to us for free. She said, no, I don't need high-speed internet. I'm fine with my dial-up. Yeah, that didn't work out long. No. It's like, she doesn't need a smartphone. Yeah, now she's got one. And then she didn't need text messaging. Like, Arlene, just try it. If you don't like it, turn it off. And she's like, oh, this is so amazing. So she's like always behind the curve a little bit. But it's R2-D2 coming. All right. So, public switch telephone network. Network of lines, carrier equipment providing telephone service. When I wired Aerospace Reports, a company way over the other side of Hefner Lake, I installed the wiring in a 2-story building, and the ceilings and the walls are all sheetrock. So basically, once the ceilings are in, you're not getting in there no more. So I wired it all ahead of time. I put in 60-some-odd network drops. I also put in 60-some-odd phone line drops. I basically use Cat5 cable for all of it because it works. I ran it all together, and then I pulled them out this side for the network, this side for the telephone. So I even asked when you want. I said, you really want this? You sure you just don't want to use voice over IP or something? No, that's what we need. I'll be darned. The moment they get it all installed, she's getting her phone service connected up, guess what? They go voice over IP. But the good thing about it is now you have 65 wires available that are not doing anything. So they could use them as a network since they were that way. But with public PSTNs, it was basically a wire to every house. Most of our houses should all still be wired with phones, I'm assuming. Okay.
Is that the principle of like a party line?
Yeah, but a party line, really there was like one main line. It's kind of like here at Rose State. Okay, I got a phone in my office that y'all can call and I can call on it. But I got another line in there that works internal only. Because what happens is Rose State has to pay for every phone line. But if we want an internal only phone line, we don't have to pay for that one. So we can call, phone to phone, we just can't call out. Kind of like a party line, you're really sharing the line with somebody. Okay? You had to wait till it was free and stuff like that. Okay? All right, plain old telephone service, we had that. And so who does not have telephone service? Anybody? That's all? The rest of you still have telephone service.
How about in the house?
Yeah, at your house, we're talking dial-up telephone. I mean, not internet, but it always gets me. People say, but I'm only paying $10 a month. Dude, you can give me $10 a month. I'm fine with that. Because don't we all have unlimited on our cell phones, basically? I mean, does anyone ever go over on cell phones anymore? It's impossible. Because it's like free mobile to mobile, and who do you call? People with mobile phones. So
You got rollover with AT&T.
yeah. I just recently switched to the mobile shared everything plan. Like, is that it? Whatever is. How many minutes do you need? I'm like, dude, I don't need many at all. I have like 3,000 or 4,000 rollover minutes because I don't use it. But no one ever talks on that anymore. Okay, but we had the old phone service, and it was good. The Murrow bombing. What was that? 95, 93, something like that. Okay, 93. 94, 95. Okay. I worked in the network shop at the time. And I remember we were just getting ready to get rid of our dial-up. Because high-speed internet was starting to come out. No one was really using the dial-up anymore. This is around the mid-90s. So we're just getting ready to turn it off when the Murrow bombing happened. They needed some way for the emergency people, FEMA and all them, to be able to communicate and share stuff. So since our network was still in place, we just gave them all access to dial into our network. And just all we gave them was a shared server. So they dial in, put files there, someone can dial in and get them. So there are good uses for it, but we all do it through the internet now. Okay? It says encompasses the entire telephone system, from switches to cabling to everything. Used to be analog. A lot of it still is analog, but a lot of it's now digital as well. Okay? You have digital data. You have computer-controlled networks, all that stuff. Eileen, she used to be a telephone operator. I don't know if y'all know that. She's probably told some of you that story. She used to be a telephone operator. You'd call, hit 0, and she'd answer, hello, AT&T, that kind of stuff. So she used to say that she would get so mad at people because she would get the perverts calling in. What color panties you got on? That kind of stuff. And she couldn't do anything. She couldn't hang up on them. She couldn't be rude. But yeah, it's pretty funny. Okay, dial-up connections. That's what some of you probably have. You just don't want to admit it. Okay. That's 56K. That's where it's at, isn't it? For dial-up, 56K is where it pretty much stopped. Does anyone use dial-up when it was like 2400 baud? No one but me? I used it when I first started learning this stuff. It was at 300 baud. I remember taking a class in Army base in there. It was near Zweibrücken. Can't think of the name now. But taking a networking class, and we had a room with terminals on one side and terminals on the other side. The old green terminals you've seen. Mm-hmm. And we would literally type it here, walk over there, and then the characters would appear one at a time. So we could literally walk there quicker than they could get there. So, and it was pretty fun. But, it worked. Then we went, 1200 baud, 2400, 96, 56K, so on and so forth. Okay. All right, the old telephones cannot handle digital. That's why they had modems. Modem stands for modulate, demodulate. It took digital, converted it into analog, sent it across the phone line, then the other end, analog back into digital. That's what modem stands for. Okay? The signal went between modems, so while I was connected to my ISP the entire time, that circuit was mine. Nobody else could use it. That's back when you used to get, all lines are busy now sometimes, or your providers had to make sure they have enough modems for that. Okay. It goes over some network. Normally goes to a central office. So if I'm dialing someone, does it really go straight from like here to my grandmother's house? Well, it goes to my central office and a few other areas, but there is an actual virtual circuit connected at that point. Okay, it's converted back to digital at the other end. Okay, the central office is where the telephone company's lines are. There's a movie. I showed it in penetration testing last year. It was the early telephone hackers with Steve Wozniak, and he was on. But there was the dude, a blind guy.
Sneakers.
No, it was actually a documentary. It wasn't the movie.
Oh.
No, this is actually Sneakers had the guy in there too. But this documentary, it has Captain Crunch, Mitnick on it and all them.
Ghost in the Wire. Well, that's a book that Mitnick had written.
Yeah, but it was on there, and this guy he was blind, and he could mimic the telephone noises. So he would literally pick up a phone and with his mouth go, and it would literally dial. Because they actually had him on film for a TV interview. And he says, "Okay, I'm going to call somebody," and then he does that, and gives the tones out. And he goes, "Okay, now it's at the switch." He gives us some more tones. He goes through the next switch, and he goes, "Okay, this person should now be answering." And sure enough, they answered.
I thought Kevin Mitnick did that.
Yeah, he did. Yeah, but
he did modems, though.
Yeah, this other guy could actually do it with his voice. I'll see if I can't find that video.
Captain Crunch guy with the little whistle.
Yeah, that's Kevin Mitnick. Yeah, we asked him to come here and speak. It was like $15,000 plus expenses. Don't have that much today. Okay. All right, we have a local loop. That's the last mile. When I got my ISP service at my house, I checked with Logix, I checked with Cox, I checked with everybody, and Logix was cheaper, but the way they were going to sell me IP address ended up being more expensive, so I ended up going with Cox. And Logix came back and said they couldn't install it anyway because they were not allowed to install this last loop, because something to do with it, if I didn't pay my bill, since I was actually running out of my house, they didn't have the right to come in and seize the equipment. They were worried they wouldn't get their money. So can't sell it. So I signed a contract with Cox. Guess who came and installed it? Logix did. Because Cox just bought the last local loop through Logix, which is my phone company. So the people who couldn't sell it to me were actually the guys who installed it. It's pretty funny because I was even talking to the network engineer about it. Then he's the guy who actually come here and goes, "Oh, I see you got it after all through Cox." I'm like, "Well, yeah, y'all couldn't do it." He goes, "Yeah, it's a stupid rule." But they could not come out and pick up the equipment. And once I finally canceled my service, Cox didn't want anything back. They're like, "No, you're done. Yeah, I had it for years, so I wasn't on the contract or anything." And that network engineer called me. He goes, "Hey, Ken, this is Steve." And he was down at the switch down the street. He goes, "Do you still have those CSU DSUs? You're using them?" So I gave them to him anyway, but I didn't have to because it was in my residence. But that was kind of cool. Okay. All right. Digital local loop is fiber to the home places. That's supposedly UVerse. I don't know. I really don't know if they have fiber to homes here. Does anyone know positively if they really have that?
UVerse?
Do they actually have fiber all the way to the homes, though? I don't think
No,
so.
they have to
yet.
lay the fiber for you to get connection.
Yeah, but
I don't know what the connection is to the fiber.
yeah. So is it actually fiber? I don't think so. Maybe I don't know. We'll see. Okay. All right. Passive optical network. It says carrier uses fiber optic cabling to connect to multiple endpoints. So maybe the backbone is fiber optic. So I'm just not totally sure on what they do around here. It's like way off the screen. Did someone hit my projector?
No, it really is all this.
Been that? Oh, okay. All right. So maybe we have our person here, our dial-up modem, our last mile connecting to a local office, which is then digital to a regional office, which goes across wherever it's going, all the way back to the other end, which possibly converts back to analog if it needs to. Okay. All right. Here's our customer's home. The last portion from your home to your central office is called the local loop, or the last mile, they might call it as well. That's the one you pay for. Okay. You really don't pay to get from the central office. I was paying, when I had my phone service, I was paying McLeod telephone. So the point from my house to McLeod was considered the local loop or the last mile, even though it's more than a mile, but so that's what that portion is. Okay. All right. Optical line terminal is a single endpoint of carrier signal. It's basically where everything comes in, where the backbone comes in. When I started working at the ISP, we handled dial-up. I actually worked with two different ISPs. When I first got internet, I don't remember the name of the company now, way back when they actually had modems. I mean, literally a shelf full of modems. Phone line going to each one, and you could literally see when people were dialing in. Then I started working at Keytech Internet. What they did is they brought in a T1 line connected to a bank of modems. It was just one card, like you would see a rack mount card, that handled 23 phone calls at a time. We had 4 of those, and we could watch. When the first one gets full, they go to the second one, then to the third one, and then to the fourth one. And we had to make sure they all didn't ever get totally full. If they did, we need to get more modems because we were running out of bandwidth. But it's just a little bit. It was an optical line coming into us from Cox, so there's no actual modems there. Okay? But an optical end is basically a fiber network coming in, connecting to whatever you have, copper or fiber inside. Okay? Oh, yeah. We have our optical units. Could be connected with fiber cable. Okay, like down Choctaw Road, there's supposed to be fiber down the road, and then they connected with copper to my place, but I still don't know if they do that around here yet. I know they do the coax, just not sure about the fiber yet. Okay, X25 and frame relay. It's been out for a very long time. Okay, it's very fast. It's an analog packet switching technology. Worked great for long distance. So it's the switching of analog signals. Way back in the 70s, gave decent throughput. I mean, you see 64K now, you're like, man, that's slow. But back in the 70s, that was darn fast. Because all you were sending is a little bit of text anyway. Then I get up to 2 megs in 92. Okay. And it says verified transmission at every node. In other words, you're positively sure it was getting there. We're great for flow control, reliability. This was a service you could rely on. Okay. All right, but it says slow, unreliable for time-sensitive applications because it wasn't like a token ring, which was actually time, guaranteed, but it was reliable. Okay, free relays. This is the analog. Now we're looking at the digital portion of it. Okay, so it's the newer one of it. Okay, with the data link layer, better error checking, overall faster. 45 megabits. It's pretty quick. More than we have now. Okay. They both use virtual circuits, so to you it looked like you had your own circuit, but it really wasn't your own circuit. Okay. Logically it appeared like you had your own circuit, but you really didn't. It's like when you're surfing Google, do you really have a direct connection to Google and you're the only one using it? No. Okay. Efficient bandwidth use, because they could actually share it with other people. Okay. All right, they have virtual switches, virtual circuits that manage all that. And they said both configurable as permanent virtual circuits. So you can actually make a connection like from here to somewhere. And it's a permanent virtual circuit for you that's actually shared. But you have access to it at all times. It's like Cox, if you think about it. If you get business, anyone here have business service at Cox? Well, if you ever had business service with them, it's actually wonderful. They get support. I mean, they'll come out at 2 in the morning, no big deal. They don't call you and say, well, we'll be out next Thursday. They come out, whatever. But they guarantee you bandwidth. So I had guaranteed bandwidth through Cox. Did that mean I was the only one using it? No. Other people were using it, but they guaranteed me a certain portion of it. Okay. I never really had an issue with it. Okay. So permanent virtual circuits are not dedicated, but they appear dedicated. Okay. You normally lease them, like most things you lease. Okay. All right. You specify where it's going to connect from here to there. You specify the bandwidth, and that all comes into the cost. Okay. Right. And basically the bandwidth is shared. But to you it looks the same. So ABC can connect to XYZ, and they have a dedicated circuit between them, but other people using the circuit as well. It's just that they are guaranteeing them their circuit. All right, lease advantages of freewheeling. You pay for the bandwidth required. An example of this is when I worked at that ISP, we basically had unlimited internet, as fast as we needed it, and we only had to pay for what we used. So if you're not using the bandwidth, so what they did is they would basically calculate an average over time. Okay? So if we had peaks of super high speed, no big deal. But overall, you know, they looked at I don't know exactly what time period they used, but they looked at that, and that's what we paid for, the average rather than the peaks in it. Right? So you pay for what you need. It's less expensive. And what's good about systems like what we had there is if our business did go up or we needed more speed, we automatically had it. Our bill would just go up automatically. Okay? Okay. It's been out forever. Everybody's been using it. And it's still out there today. Okay? Disadvantages. Throughput variable unshared lines. Your Cox cable is a shared line. So when I first got my internet in my neighborhood, I was literally the first one. That was probably the best I was ever going to have. And it still works good now. I think after I restarted my phone yesterday, I still had 27 meg download speed. So it's still good. Okay? But it is still a shared medium. Okay? All right, it says frame relay and X25 easily upgrade to a T-line, which we're going to see in a second. They use the same connectivity equipment. Okay, ISDN, Integrated Services Digital Network. Should say that somewhere. Maybe it doesn't say that. Okay, that's what it is. Okay, this was kind of like a more expensive DSL that was slower. People would have to buy this from us because a DSL you're limited to about 3 miles, 3 to 5 miles is as far as the DSL line can reach. This could go unlimited length. So, you know, it's faster than dial-up, slower than DSL, but the links were better. You could go unlimited. Okay? 99 is very popular. A lot of places use it. Could use for data, could use for voice, could use for video conferencing. That's really what they made it for originally. Okay. Use a bunch of different protocols for signaling, framing, all that setup and everything was handled. It says relies on the old telephone network. So it's actually using the existing telephone network to get this done. Okay. Okay, you have dial-up or dedicated. So you could have a ISDN line that was dedicated. Like we charged, I don't remember now, some good bucks for a dedicated connection. But if you wanted a non-dedicated dial-up connection, it was a lot cheaper. It was like $300 a month compared to $80 a month. And so we had one of those customers who would cut his connection off every night about 11 o'clock. Dial back in a few hours later or an hour later and leave it on all day long. And he's like, I'm not dedicated. I'm not on between such and such and such and such a time. And it's a big fight over that. Look, I don't have to work with that. So, all right. Okay, capability to handle voice and data, okay, on a single line. We can do that now. It's kind of like how AT&T with 4G, you can actually surf the internet and talk on the phone at the same time. Okay, you can do the same thing with this here. Okay, you have B and D, the bear and the data. One was the signaling line, one was the data line. Okay, did circuit switching for video up to 64K, so it was fairly quick, and it was a digital connection, which means it was quite fast. Okay. Okay, the data line was packet switching for call information, so it was a lot less there. And we have the BRI connection, which is pretty much what a T1 is, and the PRI, which is the primary rate, which we'll see more about that in a second. You have 2B and 1D. So you have 2 BRIs and 1 D, okay? And they carry voice and data. They did what's called bonding. Another example of this is when I first moved out to Choctaw, all we had was dial-up available. And I worked for an ISP, so I basically got free dial-up. So what I did is I got 2 phone lines. And I used both of them. Inside of Windows, I don't know if you know this, you can actually bind them together. So I took 2 56K lines, bound them together, and ended up 90 some odd usable. So it actually came quite fast. But the same thing, these 2 lines are bound together. When I got my ISP at my house, I had multiple T1s. You know, T1's 1.544 megabits per second. So if I get 2 of them, what do I get? A little over 3. Well, you don't. You get just hair under 3. Because you lose a little bit. Okay? But you can bind them together so they function as one. That's what this does here. Okay? Your maximum throughput of a PRI is basically a T1, which they're going to tell us in a second. A T1 can handle 23 data channels in one signaling channel. So a lot of places like Aerospace Reports, they got a T1 in. What they did is they ended up putting 7 or 8 of them for phone lines and all the rest for internet. And what was cool for them is they paid one price for the T1. Then they could decide how to manage this channel. They could say, I want 8 phone lines or maybe 10 phone. So I want 10 phone lines and 13 lines for internet. They're all bound together. So instead of getting 1.544, maybe they're only getting 750K.
So would it just be 64 times however many channels you have?
Pretty much, yeah. Yeah, but the maximum is 1.544, yes. Okay? And like when we ran that ISP, that's what we had. We had 23 modems coming in. And so even though you had 24s, you were only going to use 23 of them. Okay? All right. All right, here we go. We got this is our BRI link. We got the 2 in the signaling line. They connect and you can do voice and data, all that stuff behind the scenes. Okay. There's our T1. Now we have the 23 lines. And to the normal user, it's like 23/7 modems, but to you, it's really just one big old line coming into an interface. And normally they can be configured to share differently. Okay? T carriers, T1, 2, 3, so on and so forth. Okay? They worked at the physical layer. Now we're actually talking the connectivity, the cable underneath it. Okay? It's a signal channel that's divided into multiple. They can be. They use something called time division multiplexing. That's like you get a second, you get a second, you get a second. So everybody gets a second, then we keep going all the way around. Okay? That's really what time division gets for a certain period of time. Okay? It's regular telephone wire. So when I had my T1s in my house, it was regular copper Cat5 telephone wire. It could be fiber optics, but that's normally when I want the higher speeds. Okay? It could also be wireless. I had a at-link Wi-Fi. Does anyone have at-link Wi-Fi for their ISP?
Unfortunately, I do.
I actually liked them.
I don't.
Because all I had available was DSL. And I'm right over there off of I-40 and Choctaw Road. And the at-link Wi-Fi is right on the top of that tower, right there at the I-40, I-240 interchange. So they could literally stand on top of my house and see their tower perfectly. And it was great. They were giving me...
You're a lot closer to the tower than we are.
What now?
You're a lot closer to
yeah,
the tower
yeah.
than we are.
I
We lose connection all the time.
I never lost... Well, okay, I'll tell you that in a minute. But, so it's very fast. I was getting T1 speed, which is basically 1.544 megabits via wireless for the cost I was paying for, half that with DSL. And I never lost my signal, except randomly on Sundays my signal would go off. Because I hadn't changed mine because I wanted a static IP address. So they had to do me a little bit different. And one Sunday my internet went out. I'm like, what the heck? It's totally gone. So I called them up and like, oh, I didn't know you were using that frequency. Hold on a second. It's back on. I'm like, oh, sweet.
That happens all the time.
A couple weeks later, totally gone. I call them like, oh, sorry, we didn't know you were using that frequency.
That is the exact thing that happens to me about once every 2 weeks.
It's like don't update their stuff saying who's got what frequency. Because what they would do is they would keep changing frequencies to get you on the better connection. I guess they don't annotate it. So you just call them up and like, oh, hold on a second, try it now. Oh, it's working again. Thank you very much. So it was kind of weird, but a bunch of different ways it can be done. What I also liked about them, there was no contract.
Oh, yeah, that's true.
Yeah, which was very nice. Okay. All right. T1 is what I had, 1.544 megabits. It's not what you actually get for throughput, but that's the theoretical maximum. Okay. Then you have a T3, 47 megabits, and we'll see the other ones in a minute. But you can see how much. So basically, a T1 is like 24 phone lines, is what it is, all bounded together. Okay. So the higher the number, the more lines you get, and obviously the more money you pay. When back in the 98 time period, what do you think a T1 cost?
Oh, expensive.
About $1,800 a month. $1,800. We had one client. It was a mother and son who had way too much money. They sat home all day long and went on IRC. That's all they did. All day long. IRC, Internet Relay Chat. And they basically would be on there 24/7. And the only reason I know they did is because they were paying the bill every month, which is $1,800 a month. I'm like, why would you do that? But they were. And they pissed somebody off. So then a bunch of guys took them down. But since they were on us, what ended up happening was they ended up taking us down. Because they were attacking them, but they were through us. So our network went down. So we had to call Cox out in the middle of the night. Cox came out with their laptop, captured just a very small amount of traffic, then had to go into their router and block the traffic upstream. Because they had to take out like 16 Class C networks. Because it was a distributed attack against these daughter or mother and son. It was crazy. And then they're complaining at us because their internet's down. I'm like, you all caused this. And they're like, I don't want to pay our bill because our service is not blah, blah, blah. It was crazy. It was really weird. Okay. All right. So, T1, 24 channels. We talked about that. Maximum data, 1.544 megabits. So, I ended up having 3 of them, and when I finally got done, and a 3 T1s is not the same as a T3. Be nice if it was. Okay, a T3, 672, 45 megabits. Okay, it says the speed depending on the signal level and how it's done. Okay, it is fully digital though. So a lot of people would ask me, so if I have a T1 that's 1.544 megabits digital, so would a cable modem be better? That's 5 megabytes. 5 megabits. Everyone always says, why don't you just get cable modem instead? Does anyone know the answer to that? Why would I get a T1 instead of a cable modem?
Because you get a direct connection.
Well, you get a direct unshared connection that's digital, and it's the same up and down. With your cable modem at home, you get high-speed download with slow upload. As an ISP, I really needed faster upload because when you were downloading from me, I was actually having to upload it. So that's why I ended up getting it. Okay? All right. Connect branch offices, connect computers, connect ISPs like I was. T3, I don't know what we have here exactly, but larger companies, connect those, okay? 28 times more throughput, okay? And we get ours luckily from OneNet, so it's totally free. And they just approved our upgrade. They just got to finish installing it now, okay? Costs vary by region and also vary by company. Yeah. I told you the story when I got my T1, the price, didn't I? Did I tell you that, Brian? Well, real quick. Okay, I got my first T1 at $900. Okay, it was a deal because it used to be $1,800. So when it dropped to $900, I was like, sweet. So I got $900, and then Birch Communications came out. They had billboards with this dog with big glasses. They were here for a very short period of time. Well, they were installing a network out of one of my clients, and the guy was like, "Oh, I told him what I did." He goes, "Oh, we can give you a T1 for $450." Like, I'm paying $900. You can give me a T1 for $450. I mean, is that a brainer or what? So it's nothing. It's no brainer. So I call Cox up and I say, "Hey, Birch Communications in town." They're like, yeah, they knew. Obviously, they knew. And so they're offering me 2 T1s for $900, basically $450 a piece. I'm like, oh, I don't think we can do that, but we'll get back with you. So I hung up. An hour later, I get a call from Birch. Oh, sorry, we can't offer it in your neighborhood. It's not available in your neighborhood. I'm like, well, crap. They get a phone call from Cox. Well, we can't beat their price, but we'll match it. So they gave me 2 T1s for $900, even though Merch couldn't afford it. So, and then I ended up getting a third one. I ended up paying about $1,200 for 3 of them. So, $1,200 might sound, but I had quite a few customers. I had lots of people paying. So, I had 300-400 websites and everything. So, all right. Yeah, special connectivity hardware, special switching. It can be purchased or leased. Mine was leased from Cox. Okay. It says cannot be used with other WAN transmission methods. My T1, that's the only way I connected at that point. Okay. Depending on how you're doing it, might be different media. I still use copper phones, but some places use fiber. Okay. Wiring could be plain telephone wire, unshielded or shielded. Okay. Shielded is normally better, but I was out, where I live, there's nothing out there, so unshielded or shielded, there's really no interference there. Could be copper, it could be a coax, it could be microwave, fiber optic, it could be anything. Okay. It says T1s require, or shielded require a repeater every 6,000 feet. Okay. If you have multiple, you have to have fiber optic cable. Okay. And the wiring, white, blue, white, blue, green. Yeah, that's the normal wiring there. Okay. And then there's for the cross. Is that? No, that's a little bit different. T1 crossover. Okay. Yeah, theirs is a little bit different. We're not going to make those. Okay. You have a CSU, DSU on each end. A channel service unit, data service unit. Basically, what it is your T1 comes in on a piece of fiber. I mean, on a piece of Cat5 cable like this. And plugs in. We'll see a picture of it, but it just plugs in. It plugs into this little device that plugs into my router. Okay. When you take the routing class, there's actually a couple of my routers in there that have my CSU, DSUs in there. Okay. They're usually combined in a single card. Okay. It's a connectivity and it's where it ends. Okay. All right. And the DSU. So basically, we have the CSU is the signaling technology. And then we converts it to frames and basically makes it work. It's basically the multiplayer. Now, a lot of times you have smart jacks. We can actually combine them both. It's where it terminates at. Okay, could be inside or outside. Mine's actually outside my building. I have the line coming in. And they put a big old thing that can handle like 20 lines in it outside my building. Okay, that's where they can connect it at. So we have a CSU, we have a smart jack, and on the other end we got the same stuff. So my line comes into the smart jack, which connects into my CSU, DSU, which then connects into my computer equipment. Thought they had a picture. They have a picture in a minute. Okay. We have the incoming line has something called multiplexer. Okay. Remember, a T1 is 24 channels. I mentioned that. Y'all got that much, hopefully. Okay. But we have to have something to figure out a way to use all 24 channels. Okay. So we have a multiplexer for that. Okay. It basically combines the signals. And when I had my multiple T1s, I bonded them together, so it was even doing more of that. Okay. Then we could also have switches and routers. Okay. Obviously, layer 3 switches are better because they can do more than the old cheapy ones like this, but it does work. Okay. It says they may be integrated into a router. My CSU, DSU fit right into my router. So I got the router for like $50. CSU, DSUs cost $300 or $400 each. So, okay. That goes from the expansion card slotting, and there's some in the routing on class. Okay. So there we go. We got our internet, our smart jack into our CSU, DSU, connected to our internal network. That's all there is to it. Okay. And we're about halfway done with this. Why don't we stop here? We'll pick up next time with DSL and we'll finish the chapter. Does that work? Okay, we'll pick up on 49 next time.